In the last lecture, we provided a set of 3 exercises on mapping data types to visual attributes. In this lecture, we're going to give more examples of data combinations and the mapping of data to visual attributes, and we'll talk about the effects of dimensionality on the visual display. So if you have a single variable to display, or univariate data, you have a plethora of choices for visualizations. Dot plots, line plots, bar graphs, or two-key box plots are but a few of the examples. For bivariate quantitative data, the scatter plot is the most common choice. So here we have 2 quantitative variables, and the scatter plot describes the information quite clearly. Moving up to 3 dimensions, now it's getting a bit more challenging. So we can try a 3D scatter plot, but what are some of the problems? Let's look at the 3D scatter plot on the right with blue cubes. Where exactly are E and F in relation to each other? It's a bit of a problem trying to represent 3-dimensional information on a 2-dimensional surface. A better choice might be to use a 2-dimensional scatter plot with a 3rd dimension represented by some other attribute. Here we use area for the red circles for the 3rd quantitative dimension. Area is not perceived as accurately as position, so you want to put the most important dimensions on the x and y axes and save the least important or perhaps the most easily distinguished for the 3rd. Since we already discussed what are the issues in trying to map 3 variables to a 3rd spatial dimension, let's look at other ways to deal with mapping 3 variables to a visualization. So we know that 2 variables on the x and y axis can map to points. So we have scatter plots, maps, etc. Now the 3rd variable must use something like color, size, or shape. And as you can imagine, we have a very large design space. So finding the optimal mapping becomes more challenging as the number of dimensions increases. You can always use shape or different types of marks to represent nominal or categorical data. Now moving up to multidimensional data. How many variables can be depicted in an image? We've talked about 1, 2, and 3 dimensions. But what about more? Is there some perceptual limit? Starting in 1967, Bertin and others asked this question. And Bertin stated, with up to 3 rows, a data table can be constructed directly as a single image. However, an image has only 3 dimensions, and that barrier is impassable. We'll look into answering this question in the next lecture.